and gentlemen. Welcome to your Chapter 9 review. A lot going on here. I'll pause at certain parts just to get the work up on the calculator. But the first one, I'll show you how to punch this in. Okay, so when you hit y equals, start with a parenthesis. Now the next parenthesis is going to be in order to enclose basically that first numerator. So there's negative 4x. I'm going to divide that by, and the denominator I will put in parentheses as well. And now I close that whole fraction with that second parenthesis, which matches up with him, leaving me with minus 1 on the end. So when I graph that, that's what it will look like. Okay? I'll jump basically to the t-chart here in a second. But as we go through here, we get the horizontal asymptote, which we know y equals a over c plus e. A is this is c, and this would be e. So y equals negative 4 over 2 plus negative 1. So that would be negative 2 minus 1, negative 3. Okay. As far as my vertical asymptote goes, my VA, that's when I set 2x plus 5 equal to 0. So 2x equals negative 5, x is equal to negative 2.5. Or negative 5 halves, however you want to write that. Okay? And that's what I'm going to start by graphing here. So I'm going to shift my graph up just a tad. I'll leave it there. Okay? Pull my calculator up again. Go second graph. Now I have every point I need. Negative 2.5 is where your error would be. So right now that would be right here. I don't have it on there because I know where it is. I know my error. So negative 2.5, this is my vertical asymptote. Okay, my horizontal asymptote will be at negative 3, which would be this. Okay, and now we're in the business of plotting points. So, let's start with negative 2 up 7, negative 2 up 7. 1, 2, 3, 4, 5, 6, 7. Negative 1 in, I'll be up 1/3. Well, that's a dramatic decrease. 0, negative 1. Okay. And I need to jump out here a little bit. Okay. At 1, I'm at negative 1.5 now. Right? And at 3, I'm at negative 0.2. Right about here. At 7, I'm at 2.5, 2.47. Right about here. So that'll be a good representation of what my graph is going to look like on that side. Okay, so my graph here is going to go and get really flat really quick. Okay? So my arrow is on it. Now I'm going to go with my points on the other side, which means I need to get negative 3 up here. We already did 2, 7. So let's try this again. We got negative 3 down 13. That's way down here off my charts. Negative 4 is set negative 6. 1, 2, 3, 4, 5, 6. And a third. Okay. And then I'm at negative 5, 5. Which is here. Negative 6, 4.4. Negative 7, 4.1. And negative 8, and so on. Okay, so let's connect these up. Okay, and there's our graph for number 1. Okay, do number 2. Let's start with our HA. I'll do these again first. So HA would be 0 over 1 plus 3. So that would be 3. My VA is at the bottom equal to 0. So x is equal to 1. So you go do this graph. Have that match up again on the left side. So when you go to do this graph, my vertical asymptote will be at 1. This guy here. My horizontal asymptote will be at 3, which is this guy here. Okay, I'm going to pause this and pull up my t-chart off of my calculator. Be right back. So now that I have my chart up here for me to graph, let's go ahead. We'll start at 0. 0, we would be at 5. Guess I should line this up, huh? Yep. So let's go ahead and start at 0 again. 0, I'd be at 5. Just here. -1, I'm at 4. And -2, I'm at here. And that's just going to keep tapering off as we get closer to this. Off. Let's go ahead and go to the right. The right would be 2, 1. Okay, then we would have 3, 2. And then we would have 4 and 2 and 1/3. So again, we can kind of see what's going on here. Let's try this. Very steep. I can squiggle. Steep, and then my one's off. So there are our graphs for 1 and 2. Great. Let's shift down here. Don't need that calculator anymore. We have a lot of factoring to go through here, so hold on to your seat. We're going to factor him. It's going to leave me with x minus 5. 3x is already factored times. GCF of 2x, we're using it with x minus 5. And this is going to be x minus 5 times x minus 5. So, we can match him with him. We'll go ahead and match this x minus 5 with this x minus 5. And furthermore, these 3x's cancel out. So, everything basically cancels out except for the lone 2x. It's the only guy that's left. Number 2 is a little more work. Okay, I need to factor this first to find out what my common denominator is. Notice that this is addition and subtraction. So we need a common denominator before we can do that operation that they so want us to do. Okay? So your LCM would actually be x plus 4 times x plus 4 times x minus 4. That's your common denominator. So, in my first fraction, all I'm missing here is the x minus 4. In my second fraction, I'm missing an x plus 4. Okay? At this point, the denominators match up, which was the whole goal. So we can write this as x plus 4 times x plus 4 times x minus 4. Up top, let's FOIL. This is 2x squared plus 1x minus 8x minus 4. FOIL over here, it's going to be minus 3x minus 12. And this negative comes into 3 as you distribute. So, combining like terms, 2x squared, this is negative 7x, negative 10x, minus 12. I'm sorry, not 12. 4 and 12 make 16. So, over here, on bottom, I can write this as x plus 4 squared, x minus 4. The only thing you can try to do is pull out a GCF up top in order to see if this is still factorable. The good news is nothing's going to cancel out at this point. Nothing matches up. Two numbers that multiply to be 8 that have a difference of 5, no such creature exists. So you can leave it like this, or even this would be accepted. Right? Excuse me. All right. Part 3. Quite intense. First, the numerator. This is x plus 3, x minus 3. Plus 2 over x minus 3. This is all divided by 1 over x plus 3. At least we don't have to factor the second one. There's enough going on in itself. So let's start with the numerator. My LCM for my numerator is x plus 3, x minus 3. So clearly, this guy here, switch colors, needs an x plus 3. So therefore, I do x plus 3 to top and bottom. My new numerator will be 4 plus 2x plus 6 over x plus 3, x minus 3. Over here on the right, my LCM, again, is x plus 3 and x minus 3. So my first fraction, he needs an x minus 3. This guy needs an x plus 3. Okay, so x plus x is 2x. Negative 3 plus 3 cancels out. Your denominator is x plus 3, x minus 3. We still have division. So what I can do is combine like terms. This is going to be 2x plus 10 over x plus 3, x minus 3. I'm going to change division here to multiplication, and I'm going to flip this. So 2x is on bottom. This is x plus 3, x minus 3. Let's do some cross cancel. He goes with him. He goes with him. So right now, I'm looking at 2x plus 10 over 2x. But each one of these is divisible by 2. So I can reduce this down by dividing everything by 2. And that would be 1x plus 5 all over 1x. That's where you would want to stop. You could also do a GCF here. It would look like this. Over 2x, 2's cancel out. Right? Shifting down here. I'm going to solve and check. I'll do the solving. The checks I'll do when it's on pause. Two fractions separated by a minus. Make sure you cross multiply. So, distribute. FOIL. Okay, we're in the process of combining like terms on the right side. I'm going to set this equal to 0. So I'm going to add that, negative 7x, and add that, get 10. So we're looking at two numbers that multiply to be 10 and add up to 7. We do have those. X is 5 and x is 2. Okay? Let me do a check here. Okay, jumping back, you can see I knocked out the check. Here's your check for 5, right here. Okay, if you put 5 in, you'll see you'll get negative half equal to a negative half. If you plug in 2, that work for 2 is right here. Okay, and you'll get negative 2 equals negative 2. Now, this next guy. Back to the denominators, you should notice you have more than 2 fractions, so don't cross multiply. Factor it. Figure out what that LCM is, which is x plus 1, x minus 1. And what I'm going to do is multiply every numerator by that LCM. I'm not going to do anything to the bottom at all. Now all my work is up top. X plus 1, x minus 1. X plus 1, x minus 1. And then x plus 1, x minus 1. Again, all the work is in the numerator. As far as canceling goes, what do we have left? We have 3x times x minus 1 equals, what cancels out? Him with him with him, nothing but 12 left. Plus, nothing cancels out here. So I'm going to FOIL this while. This is x squared plus 1x minus 1x minus 1. Distribute in, 3x squared minus 3x. This is 12 plus. These cancel out, so 2x squared minus 2. Don't even need that parenthesis anymore, sans. So, what do we got here? I'm going to subtract 2x squared over. That's going to be 1x squared minus 3x. 12 minus 10 is, 12 minus 2 is 10. I'm going to set this equal to 0. And again, two numbers that multiply to be 10, this time make 3. So negative 5 becomes positive, and this becomes negative 2. Right? I'm going to knock the check out. So, as far as the checks are concerned, here is my work for 5. If you plug 5 in, 3 times 5 is 15. 5 plus 1 is 6. This is 2 and a half. And then 5 squared, 25 minus 1 is 24. That's a half plus 2. Yeah, that works. Plug negative 2 in. You're going to get negative 6 over negative 1. Then you're going to get 12 over 3, because negative 2 squared is 4. 4 minus 1 is 3. So, didn't mean to make that jump there. Okay. So what you see here is, you're going to get